All right, greetings, folks. I hope you'll be able to tune in here as we go along. I'll be on from out of 2 or so. I guess I'll do that in one big video. And if you're having to watch this later on, you can jump around in that video if you're not watching it live. Um, Jump around, see different parts of it. But I'm going to try to ask questions as we go along. Hoping there's some questions on the lab or the other work that you're doing now. And then I'm going to try to set up this pattern and do the introduction to the big topic for next week, which is regular factoring. So I hope you can join in on that. I think my approach to factoring is a little different from what you'll see in the book. There is a lot of videos using this box method, which kind of combines a lot of the methods that are in the book. Almost all of the different methods described in the textbook can be done by this box method instead, and it takes care of a lot of the work. And we've been doing enough multiplication that way that I hope we're set up for it well. But I'll do the lead into that now during today's session, along with whatever questions you have on the existing work. So I'm going to get this set up so that it's looking at the paper again and calculator, although I don't think we'll need calculator much for factoring. The numbers aren't that big a deal. But let me get this set up and certainly chime in with questions or problem solve from the lab or anything that you have as we go along. Try to move slowly and hope this thing will keep into focus here. But I want you to send, as you get this lab done, there's 4 pages on this lab. I want you to send in pictures or scans of that. I've got a few of them already. People that got that finished ahead. That's looking good. I concentrated on GCF in there because that's the first step in our factoring, in any kind of factoring, is to look for a common factor to all of the terms first and get that pulled out. So we got some experience with that. But it's also going to be a step as we go along with this box method factoring, the factoring out the GCF within that sort of grouping that we'll have in the box. We'll see where that comes up again. And so being super good at GCF is a big advantage here. So I'm going to work some of these problems out of the textbook, but I'm just not using the methods as they kind of describe it in the textbook. We're doing the same thing. We're just really arranging it a little differently. And we go about the factoring, but I want to do a couple of multiplication problems just to observe the pattern that we're going to be taking advantage of here. So I'm going to start actually with an unfactoring kind of thing where we're just doing the multiplication of a couple of binomials. So we've been working on these for a long time. But if I have something like 3x minus 2y and x plus 4y, neither of these is a monomial. So they're factors that are not like GCF kind of factors. This is the kind of factors that we're looking for now. But think about how we multiply those out. If you arrange them using this box thing, we keep track of the pieces in an interesting way, and there's another pattern we want to look at here. So if I do out the multiplication of x minus 2y times x plus 4y, I got 3x squared minus 2xy plus 12xy minus 8y squared. Now, when we're doing the multiplication, what we do is combine the like terms. There happens to be a couple of like terms on this, so we put this together, and the expanded form is 3x squared plus 10xy. That's positive 12 and a negative 2, so they combine to 10xy. And I have minus 8y squared. Notice the last term came from this box, and the first term came from this box. And those oftentimes are your like terms on these that combine to add up to this. There's one other pattern I want to catch with this, though. If we just look at the numbers in here, the 3 times the negative 8 is negative 24, and 12 times negative 2 is negative 24. I think we pointed out some of these in class before break, a long time ago now. That pattern's always going to happen because of the numbers that you have out here. This times this, and this times this. When you multiply that, you've got the same product you're going to get if you do them in the other order. So long story short, those two products, sort of the multiplication here and the multiplication here, those two products are always going to match up. Even a letter apart, these would both be negative 24 x squared y squared if I included the letters, but it's the numbers we have to think about. This is what we have to find when we do this backwards. When we do the factoring process, we're going to be starting with this 10. We're going to have to turn that 10 into these two numbers that add up to 10. But we have to pick the way that adds up to 10, but also multiplies to that negative 24. So while we've got that there, I'm going to go ahead and do a factoring problem now to introduce how we're going to use this box the other way. Think about doing this whole thing backwards. So I'm going to grab an exercise from chapter 6 that starts off in the multiplied form, and we're going to go back through it using this kind of technique. So we start with u squared minus 8uv minus 24v squared. We really are working backwards on this from what we did here. I'm starting with this expanded form. I have to work this back out to find these things that'll tell me my factors to it. So I'm going to see how this looks in that direction, and this is what we're doing. Most of chapter 6 is about this. So as I go to put these things back into the box, we're going to do this from the inside out. These terms tell us what goes into the box, but the first and last terms go here and here. So the u squared and the negative 24v squared have to be here and here. These are the two interesting terms. Those two things have to add up to negative 8, but they also have to multiply to this product. This is a 1, really. So 1 times negative 24 is also negative 24. I happen to get the same number there. But I need two numbers that multiply to negative 24 that also add up to negative 8. Is that even possible here? Okay, turns out this might not have been a great example to start with. I'm thinking about negative 24 now. I can make that negative 24 times 1, or negative 12 times 2, or negative 8 times 3, or negative 6 times 4. None of those are adding up to negative 8. That tells me that this thing does not factor. I picked an exercise that's an impossible one to start with. I mean, the fact is we're done with the problem, because if you can't find numbers that do this, that means you can't factor that thing. It's already as simplified as you can get as far as factoring it. That's what we call prime. So that was a tough one to start with, but we don't actually find the numbers. I don't get to go through the process. Manage that. Well, that's what it was. Okay, I'm going to do a different example. So this, if we're just trying to factor it, we're just going to answer prime on that kind of thing. We will find some that are impossible to factor, and that's what we're going to call them. I'm going to tackle a different one now that we'll work through. Similar kind of setup. Start with this expanded form, try to work our way through it. finding the factors on this. So I got room for one more here. This page. A couple of folks on board. Drop into the chat there if you have comments, questions, if you have topics you want to get back to on the lab or something. Just drop a note into the chat there. I'm keeping an eye on that. First and last terms are going to go right into the box. So I know this is going to be a 2x2 thing like this. And the first term, all of these two kind of squared terms go here and here. And my number this time is 1 times negative 80. I need two numbers that multiply to negative 80 and add up to negative 2. That's got to be the pattern here. Now, some people can think about negative 80 and just kind of mentally play around with it and come up with the two numbers that would also add up to negative 2. You might be able to do that. It's negative 10 and 8. But I'm trying to make this a procedural thing. A lot of people can stare at stuff and kind of see things. That's not a method. So what we got to think about is all the possible ways to multiply to negative 80. That's a pretty short list, actually. There's only so many ways with integers to multiply to negative 80. So it could be 1 times negative 80, or it could be 2 times negative 40. 3 doesn't go into it evenly. 4 does. 4 times negative 20. 5 goes into it evenly. 6 doesn't. 7 doesn't. 8 does. 8 times negative 10. And if I kept going, I could get 10 times negative 8 and so on. I could keep on. I'm really just going back through the other numbers. But this is the one that I wanted to get to. That's the only one that's also going to add up to negative 2. That means that negative 2xy is going to break up into these two terms, positive 8xy and negative 10xy. So I have a handout on this stuff with some examples written, but it's really, I think it's one of the things that's really better to see it kind of work through in order, the process of it, so you can see how this goes. We've got the inside of the box filled out, and now we're going to inside out it. We're going to take out pieces out here that'll actually be the answer to it. But the key step to the whole thing is if there is two numbers that multiply to this and also add up to what they're supposed to here, then it's going to factor. The rest of it's going to be real easy to do once we get these things filled in. The letters in here are predictable because the only way they can add up to this is if they're like terms. They have to be XY terms. It's the numbers that we have to find, and now we've got them. Now we're just looking at a GCF problem again. These two numbers in this row, these two terms in this row, the GCF of those two is just X. So that's what comes out in that row. These two numbers in this row, these two terms, negative 10xy and negative 80y squared, both negative. So I'm going to have a GCF of negative 10y there. They don't have, this one doesn't have an x, but they do both have at least one y. So that's my GCF right there. Do the same thing with the columns of this, right? When we have the multiplication, we need to know these values up here, and we need to know these values up here that go with the columns. So I'm going to do the same thing with the columns here now. X squared and negative 10xy, common factor is x. This and this, the common factor is 8y. I've already got the minus down here that takes care of that row. These are the values, so this is positive. Those are my two factors then. That's my answer to this problem, the factored form. X plus 8y and x minus 10y. If you think about multiplying this thing out, you'll see how it goes right back to these terms, combines to that. So you can easily check when you've got the factors down. It's pretty easy to do the multiplication, work it through and check this, but pretty easy to see here that these things multiply to that, and this multiply to that. That's going to happen as long as there is two numbers that behave like they're supposed to here. The rest of this stuff is going to work out great. So we got to get good at that process here. Taking the polynomial. We're doing a bunch of three-term things first. That's what we're concentrating on. Putting that first and last term in there, and then splitting up that middle term using those two numbers that fit that pattern. And then just pulling out the GCF of each column, the GCF of each row. Those are your factors for the answer. We're going to work through a bunch of those. But I didn't mention it here. One key to making all of this work is that I really have to look at it before I start any of that. I have to see if there's a common factor to all of these. That should come out first as a separate factor if there was a GCF to all these. But it turns out there's nothing in common with all of these terms, except so the GCF is 1. There's nothing to factor out here. That really has to be taken care of first. But once that's done, if there is a GCF, factor it out. Take what remains from that, work it through this process. It's going to take care of the different factoring techniques, any kind of three-term factoring. This should do the job for it. We got to get good at this pattern. And the letters are pretty predictable. These happen to be two variable things, but the letters aren't hard to figure out here where those are going to be. The numbers, we have to work through this numerical pattern and see what's happening with the numbers. But once we know what they multiply to, it's not that big a list of possibilities. And if there isn't anything that adds up to what it's supposed to, then we know it's prime. There's no trial and error involved in this. And that's what I kind of liked about it. You work through this process and you know for sure if it doesn't factor. And if it does, you should be able to find it from here. If there is numbers like this, then the factoring is going to work and you are going to get factors. So there's a lot of certainty to that. I like that. I might have to try to target this thing to people watching it later because I don't have a lot on right now. People might drop in anytime, but I'm going to try to work through some examples as people can watch this later on and jump through it. They can see examples that'll tie into next week's work. Could do examples of the stuff that we had from this week. Some of the GCF stuff will be built in. Don't have any questions to get back to yet on that. So let me get a fresh page going. I'll work some more of these. I think I found lighting that's fairly good for this. That seems workable. Grab another exercise from here. Factoring. So I'm hoping these Friday sessions are going to be more question and answer as we go along with more content. But if I don't have a ton of questions, I'll use it as intro to what's coming up. So Monday, I'll be sending out the announcement links again through Blackboard on Monday and get a new assignment up on there. This will be the content of it. It's going to be concentrating on this factoring process. There's a couple variations, this basic pattern that we keep using. All right, I'm going to jump up to one of these. Okay, here's another three-term factoring problem. It's asking me to factor 3m to the third minus 21m squared plus 30m. We don't really need to do a ton of classifying here. You need to recognize it's a three-term factoring problem, but the process is the same. Step one is to pull out the GCF, and then we're going to go into the box with it once that's done. So I need to be able to identify the common factor from these things. This is what you had on the lab for this week, was looking at some of these things and picking up the GCF and then factoring out the GCF. So what can go out here, and then what's left inside one side divided out. Numbers are all divisible by 3. For the letters, I got 3, 2, 1, at least one M, so I can take out one M as a common factor right there. Divide them all by 3M to see what's left on the inside. So 3 divided by 3 is 1. M cubed divided by M is M squared. Negative 21 divided by 3 is negative 7. M squared divided by M leaves 1M. And then 30 divided by 3 is 10. M divided by M is 1. So I just have the number there. All right, the box method doesn't work nicely if you don't get this out of the way first. If we didn't pull out that 3M, it would get in the way of how this whole box method works. So we want to make sure that happens first. And the other good news about that is that I got a lot less complicated problem to actually factor here. This is taken care of. It just stays on the outside. I want to know what the factors are here. So really what I want to do is be able to write this now as 3M. If it can be factored into these two pieces, I want the completely factored form like this. Now, some of you can probably look at that and think about what the factors are. And you already know how to do that kind of with trial and error or whatever you do there. That's fine. I want to think through the process deeply. We're going to get this a little more complicated as we go along, but they all fit this pattern. If there's 3 terms, we break up that middle term and work through it. So I want to think through the pattern here, and I'm doing ones that start off fairly simple here. And then we're going to get a little worse, not terribly worse, but a little bit more difficult numbers. So I'm going to do the rest of this factoring by the box. We'll be able to fill in the answer up there. This will work nicely for anything that factors into a binomial times a binomial, which is what we're doing. That's what all these are. Almost all the factoring that we do. First and last terms are M squared, so that goes here, and 10. When we're doing these one variable factoring things, that last term is just the number. Fine. These two are the magic things. Now the letter part here, these have to add up to negative 7M. So they have to be something M. It's just finding these two numbers that we need. That add up to negative 7 and multiply to 10. This is 1 times 10 is 10. So I need numbers that multiply to 10. Now that could be done with positive numbers, but that's not going to add up to negative 7. But you can also multiply to 10 using negative numbers. They'd have to both be negative. So there's the one that's going to work here. Negative 2 times negative 5 is positive 10. But they add up to negative 7. So when we see that minus there and a plus here, we're going to end up with negatives in both of these places. Now, the way this pattern works, to get to positive 10 down there, we end up with a negative in each factor. Both of these are going to be minuses because that's going to give us a positive 10 back here and take care of these negatives. So when the negatives are on this diagonal like this, you're going to have a minus in both factors. You need to go inside out. Now we got the inside coming out. It's just finding the GCF for these things. And that's just M for this column. GCF here is 2. 2 or a negative 2, but I know I want the minus there. So that's M minus 2 is one of the factors. And then count rows. Common factor here is M. Common factor here is 5 or minus 5. I want negative 5 here. So that's M minus 5. Those are the factors that multiply to this. That's your completely factored form of that problem. Process is going to be exactly the same if there's a number. I see how this was just M squared. That makes this part of it really pretty predictable. You're not going to have anything going on here if they're going to multiply to M squared. That's kind of how that has to go. But this same numerical pattern works. If there is a number there that gets broken up, it's still part of this diagonal. We'll be able to work this through. It's kind of handled differently in the book, but it isn't really a different process if we have this box working. So I'm going to follow through one of these where we have a number with the squared term. See how that affects things. We can do (5x squared). So we're trying to factor 5x squared minus 17x plus 6. This is actually exercise number 100 from chapter 6 in the book, but we'll do a bunch of them. Step 1 is to look for a GCF, but there's no common factor on all of this, so I can write this down, but there's nothing to do here. GCF. There's nothing that goes into 5 and 17 and 6, and there's x's in some of the terms, but not all of them. So there's nothing really to do here. The GCF is 1. Dividing by 1 doesn't change anything. So this is really what I'm dealing with. I'm trying to find factors that come out to this whole thing. This is what I'm trying to do. Regular factoring problem. No GCF financing. So in the box that I look at, first term is going to be 5x squared. Last term is going to be 6. These two are going to be x terms because they have to add up to this x term. I got to have something x and something x. They have to add up to negative 17. They have to multiply to 30 now. You see the 30 comes in. That's where this 5 makes a difference because we're dealing with this diagonal. 5 times 6 is 30. Positive 30. I need numbers that multiply to positive 30. If they're going to be add up to a negative, I'm going to need them to be both negative then because they multiply to a positive. So how can I do this with negative numbers? There's a few different ways you can get 30. I'm going to write down kind of the factoring things. Now, if you're not super good with your arithmetic facts, this could take a little bit more work thinking what goes into that and stuff. 4 doesn't go into it evenly. If you do 30 divided by negative 4, you're getting a decimal. We don't care about those. That doesn't go. 5 goes into it evenly. Negative 5 times negative 6. And then with negatives, that's really the only possibilities right there. We needed something that added up to negative 17, and we already got it. So I really didn't need to go that far with the list. But this is the combination that's going. It's the only combination that adds up to negative 17 and multiplies to 30. So the two numbers are negative 2x and negative 15x. Now you might be thinking, how did I know which one to put into which place? And it really doesn't matter. So I'm going to go ahead and work this out both ways so you can make that comparison, right? What if I took those two numbers and reversed them? How is that going to affect things? So I also want to put the negative 2x here and the negative 15x here, and we'll kind of see how it affects things. But final answer is going to end up the same. That's a long story short. I have to think about GCF now. Here's the key to this. Once we got the inside done, we're going inside out by thinking GCF of just these two terms. The book calls this, well, the book describes a factor by grouping technique. We've really grouped them into rows and columns instead of grouping them in a big long thing. But it is really grouping that's going on. We're grouping them into these two columns and these two rows. The GCF of this column is 5x. The GCF for this column is 2, but I know with the minuses here, I want to go minus 2. I could go plus or minus, but the negative 2 will make this come out right. And then the GCF for this row is just x, and the GCF for this row is just 3, but 3 or negative 3. I want to go negative 3. Those are the two factors. Now, if you're not super good at looking at it and coming up with the GCF, I have good news for you on that. So you really only have to get one of them. If you look at these two things and you see the 5x goes into it, well, we want this times this to equal 5x squared, so that's what this has to be. And once you know what this is, x times something has to give us minus 2x, so that would have to be a minus 2. And negative 2 times something has to give me 6. That would have to be a negative 3. They are the GCFs, but once you get one of them, you can tell what the rest of them have to be, because we need these little multiplications to work. Negative 2 times negative 3 is 6. 5x times negative 3 is negative 15x. You can kind of check the problem right here that you have the right stuff. If all those little multiplications work, then it sure is going to combine. It's going to be equal to this. So those are my factors. 5x minus 2, x minus 3. Now, this one off to the side where I wrote them down in opposite places. Watch what happens with this now. The first row has the GCF of 5x. This has to be my negative 3 over here now. This has to be my minus 2. Common factor here is x. I'm getting those same two factors. I kind of switched rows and columns, but I'm getting the same two things as factors. It's still x minus 3 and 5x minus 2. So those are interchangeable. As long as you have the right two numbers, everything should go your way. Just got to get used to that pattern. All right, got a question to look at from the lab here. So that's good. I'm going to turn the page here, and we're going to work on some of the subtleties off from the lab problems. That's good. Hold on. So this is a division problem. Well, let me get it up. Division problem. Copy this thing down first of all. And this will tie into the new stuff that we're doing also. This is really the groundwork for that. But this divided by 6x to the 5th. Question is whether to take that GCF out before setting up long division or after. But honestly, long division is not really the right word for it, because here this is just a one-term thing. As long as we're dividing by something that just has the one term, we don't want to think in terms of long division. We want to think in terms of term by term anyway. There is a common factor, a GCF, that could be pulled out of this. That's not really necessary here. When we're doing this one term division, it's not actually, they're not all divisible by this, but we're going to do it, take it apart and do it term by term anyway, just get fractional piece to it. So you can go right into the division form, but the simplest way to write these when it's a one-term problem is just everything over 6x to the 5th. All of the terms become fractions. Some of them will, well, all of them will simplify some, but some of them are going to stay fractions. So you don't really have to think about a GCF on this. It doesn't really help you here. We want to think about simplifying each one of these little fractions. That's it. 30 divided by 6 is 5. X to the 6th divided by x to the 5th, that's when I just subtract exponents. If it comes out positive, great. We just have a term like that. This is positive 8. 5 minus 5 is 0. The x's just cancel on this one. That's just the number 8. And 36 divided by 6 is 6. Here's where we get a fraction, really, x to the fourth over x to the fifth. If you do 4 minus 5, you get -1. I could write x to the -1, but the proper way to write it is with positive exponents only. It's really an x in the denominator. So we're going to end up with this fraction thing in there. If you use the GCF, you can simplify it differently, but you're going to end up that situation where there's too many x's on the bottom in this piece. You're going to end up with a denominator out of it. So that's the right form to end up with. The ones that are really long division problems, sometimes there's a GCF to pull up. That's not really helpful to us in this kind of thing. We want to do the division, even if it doesn't come out even. We're just going to have the fraction piece. So we don't really deal with GCF in those separate kind of question. While I'm looking at this lab, I do want to work through one of these that is a more than one term thing, that is a long division thing. And there's one of those, as I remember. Doesn't come out so nice. Yeah, number 5. I want to work through number 5. Maybe people are doing okay on this, but it wouldn't hurt to get another written example to look at. So if you've tried out number 5, follow along with this. If you made a mistake along the way, you can correct it now. Number 5 from the lab, which is, let me copy it down first, and then we'll set it up. Long division form. Nice descending order on this. The way they have to be written for this all to work is your nice descending order: 3, 2, 1, constant term. X term, constant term, normal way that we write these things. But as soon as we recognize there's more than one term, I know I want to go to the long division form on this thing. So I'll work through that. Copy this thing down inside. We're dividing this. And all my columns are in here. I got an x cubed column, x squared column, x column, number column. I can keep it all straight with that. Nothing's in that. Off to the side, I want to work the first term divided by the first term piece of this. 15x cubed divided by 5x comes out to 3x squared. Wait, that was a negative 15x cubed divided by a positive 5x, so it does come out negative there. Like that. Now, that just tells me the first piece of the answer. It's negative 3x squared. So if you got that far, that's the right way to start on it. But then here's where we got a bunch of terms and we got to keep track of things a little bit. Yeah, negative 3x squared times both of these. Now this is the first part of my answer, so do out this multiplication. Negative 3x squared times 5x is negative 15x cubed. And negative 3x squared times 4 is negative 12x squared. The subtraction you have to be super careful with on this because we got negative things going around. It's easy to get tangled up. So this is where it might go wrong. You can see that this minus that is 0 because these should be exactly the same. We set that up. That should always subtract to 0. But this is negative 32x squared minus negative 12x squared. They're x squared terms, that's fine, but negative 32 minus negative 12 is the same as negative 32 plus 12. It comes out negative 20. We have to be careful about the subtraction there. If you like, thinking in terms of adding the opposite, you could run through and distribute the opposite there. It's just a different way of writing it. But if you want to come through and think, since we're doing subtraction at this step, you could go ahead and distribute it through and say plus, and then you're doing addition. Negative 32 plus 12 is what we ended up with. So that's another way to write it, but this is what you end up with at the next step here. Now that's my first term. Now I still have this other stuff I haven't gotten to yet, and this is the parts that I'm dealing with in the next step. So start over in the sense that we're doing first term divided by first term, but now my first term is negative 20x squared divided by 5x. Is that negative 4x? So we're working our way down in powers here. Powers are coming down, we're working our way through it. Negative 4x is the next piece of my answer. And I'm going to multiply that by this whole thing now also. Negative 4x times negative 5x is negative 20x squared. That looks promising. And negative 4x times 4 is negative 16x. It just seems like a lot of repetition is good at this stage because there's a ton of pieces moving around in weird places for algebra. And we have to be really careful not to throw things off. So I want to look at a lot of examples on this. Subtraction here comes out 0, because those are the same. Subtraction here is really adding positive 16. This is 4x minus negative 16x, or if you distribute it out, it's 4x plus 16x, so that comes out 20, positive 20x. Like terms, all the like terms are staying in their nice column. That's my first term now, and I'm dealing with that one, and the next one as they go through. That would be my stage on this. First term is now 20x, so that's my little division now is to do that divided by 5x. Get the next piece of the answer there. That comes out positive 4. So that should be a plus 4. And multiply that by both pieces. So 4 times both of these, that's 20x plus 16. And subtracting, that's going to come out 0 entirely. I'm a little, becomes plus and negative on both of those. Comes out 0 entirely. I'm a little bothered that the ones that I picked for the lab here all came out nice and even like that. We got a 0 remainder, so we don't actually have to write out the remainder over 5x plus 4 here because it's a 0 thing. It happened to come out even. They don't always come out like that. But the ones on a lab did. So that was a good start on the simpler ones. If you have a number left here, you can't really go any further with it because you can't do a number divided by an x with polynomials. So if you have a number left here, it's your remainder, and you're going to write this is your answer, this is your quotient plus remainder over 5x plus 4, the thing you're dividing by. Stays as a fraction piece. But if your remainder is 0, 0 over anything is 0 anyway. Don't really need to write that. There we go. We just have the quotient for those. So in some of these problems in the homework, it asked separately for what the quotient is and what the remainder is. Instead of having you put this together with the fraction piece, you could answer the two separate questions. But the quotient is these terms that we ended up with, generating one at a time up here. That polynomial is our quotient, and the remainder is just the thing that you end up with down here, in this case, 0. So if they're asking for quotient and remainder separately, that's how that answer would look. Anything else off from this lab? That was some of the longer problems on it. All right, I'm going to keep rolling along. along with the box method factoring examples then, because if people jump into this later on, I want them to see what's going on with that. Certainly take more questions as we go along too. I should get new homework up. In the Lumen homework, I should get that up later today because we're ready to get going on that soon. I'll have to get that put together. All right, another factoring problem. Let me clear some space to do that. I'm going to have to get more of these legal pads also. I'm running up through a lot of paper. All right, I'm going to take another one out of factoring problems. We got some good ones in the textbook. Document. So here's another factoring. And I'm jumping into some fairly involved ones. So I wouldn't really recommend if you're going through practice exercises and this stuff, you should do, quite a few of the simpler ones, getting used to the pattern as you go along. I want you to see how this pattern applies when there's a little bit more complicated numbers going on. And that's all that happens here is we're dealing with the same kind of thing. We're just dealing with a little bit bigger numbers. There's a lot of ways this could look in factoring, right? If I was trying to think directly to the answer, which that's not the way I approach it, but if I was trying to think directly to the answer, I don't know if this is going to be A and 4A, or if it's going to be 4A and A, or maybe it's 2A and 2A, right? There's various possibilities there, various possibilities for the B terms. I don't know what any of them are from just looking at it. So this is really where this box takes care of a lot of the work for us. You can go through the different possibilities there and just try to find something that comes out right completely. But I don't like trial and error. If that's algebra, we don't usually use trial and error stuff. We generally have procedural ways to do it. So this is a very procedural way to do it. Step one is to look for a GCF, and then we're going to throw it in the box and go from there. Should fit. Look for a GCF, but the GCF is 1 on this one. There's nothing those numbers all have in common as a factor. And there's no letters that are on every term. So there's no GCF to factor out. So I'm going to go ahead with throw them into the box here. The first term and last term go in just fine. And then I got to work my numbers to see what these are going to be. I can tell they add up to this, so they have to be AB terms. Something AB and something AB if those numbers exist. Well, let's see, they would have to add up to 17. But right, you could go on all day with things that add up to 17. But they also have to multiply to something here, and that's where we get a short list. 4 times negative 15 is negative 60. So in this diagonal multiplication, I got negative 60. If I'm just using integers, there's only so many ways to do negative 60. And I got to find off from this list what adds up to 17. But multiplying to negative 60 means one of these has to be a positive and one of them has to be a negative. I need a small negative and a big positive, so I might start here and work my way through it this way. Got the list of the possibilities with opposite signs because they multiplied with negative. 2 goes into it. 3 goes into it evenly. Right, I could keep going with possibilities, but look, I just found the magic one there already because that adds up to 17. And that's the number here that I'm trying to get for that middle term. So the number is 7. The numbers are negative 3 and 20. The terms are negative 3AB and positive 20AB. and it doesn't matter which is which. Those are the inside of the box. Now you gotta go inside out, pull out the common factor of the rows and columns. Now we have a column that's all negative right here. So if you look at these two terms, common factor of 3b, but when they're both negative like that, the GCF, we're going to use negative 3b for that. That's kind of why they had those, why I included those on the lab where you were factoring out a -1 from it, because if this pattern, if both of them are negative, your GCF can be negative, and that takes care of all the negatives on here. This will be positive stuff over here. The GCF for this column, 4a. For this column, 4 and 3 don't have any common factors. On this row, I mean, this is a row, but 4 and 3 don't have any common factors, but the A is in both. So this is A. It's at least got the letter part. B here, while 5B here. You can see the little multiplications are going to work. That this times this is -15b squared. 5b times 4a is 20ab. All the multiplication patterns that we had a little time to get used to. We're just working through those same patterns backwards. But we got our answers here. 4a minus 3b, a plus 5b. If you think through your foiling thing on this, you can see 4a squared, -15b squared. And the inside and outside terms are the ones that add up. That's your -3ab, and that's the 20ab. Those were the two pieces that we needed in there, but they add up like they're supposed to. So everything works out for that factoring. If there isn't nice binomial factors like these, then there isn't going to be numbers that work. You're going to go through a finite little list of possibilities down here, and if you don't find anything that adds up to what it's supposed to add up to, and you can tell that's going to be prime, there's nothing further to do with it. It's prime polynomial. Factoring numbers is actually a very, very hard thing mathematically. If I wrote down a great big, like, 5-digit number or something, finding all the factors of a number is one of the very more complicated things in mathematics. Polynomials, well, really, it's the numbers that are the hard part. The letter pieces on this are pretty easy. And we're not going to tackle ones with crazy numbers in it, so we don't have to think about that too much. But the fact is, some of them are prime. So if I wrote down a great big number, it might not have any factors at all besides 1 in itself, right? That happens with numbers. 20 has a bunch of factors, but 23 is prime. It can't be factored. Same thing with polynomials. Not obvious which ones are which, but some of them are prime, and some of them can be factored. And this pattern of whether there's a pair of numbers that multiply and add up to what they're supposed to, that's really the key to the whole thing, to know which ones are prime or not. So it takes care of all the factoring patterns that we have there. So I found some YouTube videos that I'm going to link out to Monday that go over this, but they don't always explain the whole GCF part of it. But they'll use this box method factoring. I don't really like how the textbook approached this, because if you read through the textbook examples on it, it makes it sound like there's 12 different kinds of factoring going on to me. When I look it over, it looks like there's this pattern and this pattern and this pattern. They're all kind of wrapped up in here. Almost every factoring that we do is GCF, and this box will take care of all the different factoring except for some difference of cubes. That's one exception to it, but almost all of the factoring we do can follow these exact same steps. So if you're a procedural thinker, let me go through and kind of think procedurally about what we did to solve this. This is what you'll be doing a ton of practice with next week. Step 1 is always to factor out a GCF. didn't write anything on this one because the GCF was 1. There was nothing to factor out. So I'm going to write the steps here. That's always the first thing to look at. The box will not work nicely if you have a GCF and you don't get it factored out. It's going to tangle up with everything that happens in here. So make sure you do that. If there is a GCF, factor it out first. Then first and last terms into the corners of the box. Right, we could tell immediately where the 4a squared goes and where the negative 15b squared goes. So get those put into there first. The other two are the ones that combine a little bit, where there's into the box next. I know the letters have to match what's here. If your middle term, whatever letters are on your middle term, that has to be here because they're like terms. They add up to this. They have to be like terms with this. So the letter part's the same. I like to put that in first with room, and then we got to find the numbers. So this is your diagonal multiply. And from that you find factors that add up to the middle number. Take a look at this. Okay. Something about my connection said it was unstable, so it jumped off for a minute there. So I don't know how much of that you got. Let me get back into this. I'll write out the steps of what we did here. So let me describe this last step. This is a little off now, but we'll try to jump this back in. It's a big step to this. Once we've got the letters here and here into the box that match the middle term, now we got to make the numbers match up. So this is describing what we did here. Diagonal multiply, find factors that add up to that middle number, with 17 in this example. So then we can fill in the box. We put those two numbers in. And what I'm calling inside out here. Write down the GCF of each row and column. 2 rows, the 2 columns. The GCFs give you the numbers on the outside of the box. Those are your factors now, so you can write the factors down. Your answer to these kind of things is the factored form. Okay, so we got a little fuzzy. I'm trying to say all this stuff out loud because my handwriting's not great, especially when focus doesn't seem super great on this camera, but try it out. So that's the process. I'm writing it out like that makes it seem pretty long, but some people that are more procedural thinkers or like to put things into words, there it is, kind of in words, what we did. Examples are how to understand this thing better. Numerically, there's not a ton going on here, so I have a calculator sitting here and haven't been using it. Numerically, the trick is when you're filling in this table, we got to be able to take the number and think about our multiplication stuff. When we get bigger numbers like that, there's a little bit to think about here, what goes into it evenly. You only have to go down until you find what works, but there's a little work in there knowing, or I was just doing this division out. You might use a calculator for that when the numbers get a little bigger. Trying to concentrate on the pattern here so we don't go with crazy numbers. We're not going to run into great big numbers on this, but concentrate on the pattern of what's happening here. Now, this will work if there's problems like this that have 2 different letters in them. It'll work with 1 letter problems. It'll work with other patterns on the exponents. And I'm putting it off for now, but it'll work with 4-term factoring problems also. Actually, the box contains spots for 4 terms. So the 4-term factoring problems actually end up being easier, but I'm gonna put that off for now, try to get the pattern down. On the 3-term factoring, which is the bulk of what we do in this class, is GCF and 3-term factoring problems. Again, I haven't given any reason why we would care about this. What we accomplished on this grand example is we took a polynomial and we wrote it down in a different form. These two things that if you multiply them out, it's exactly the same as what we started with, but we have it written in this factored form. It's kind of a neat puzzle thing. You can check your answer nicely. Some people get some satisfaction in being able to solve a puzzle like that, but we haven't actually accomplished anything right yet. We're going to see how this is actually very useful in a couple of algebraic settings, how it actually helps us solve for something or simplify something. But we're really not doing that now. We're just finding factors and getting something written in a different form. A lot of what we do in algebra is just writing stuff into different forms. Get used to that. Let me get a fresh page here. We'll see what else can happen with this. Yeah, here's one that I don't know whether it's going to factor or not. I mean, I like this pattern, but I'm not able to tell these things without going through the steps here a little bit. 6p squared plus p minus 22. I don't know whether that factors or not, right? Maybe there's a couple of factors. Maybe there's not. I have to go through numerically and see what happens with this. So, try it out. First thing I should look for is a GCF on this. Something that goes into all of these terms. There's no letter that's in every term, and there's no number that goes into all of these things. So the GCF is 1 again. It doesn't help us, but we got to look for that first. I'm going to take that step first. No GCF. I'm ready to go on to the next step of putting the first and last terms in here, and then the letters in the other two boxes. 6p squared. And then I call them first and last terms. You write these in the standard order up here, and your first and last terms go right into the box with no problem. And the letter from here, this is a plus 1p. The letter is just p, so these have to be p terms right here. Can't have any different letters going on because they add up to this. Numbers have to add up to 1. I'm leaving some space there. These numbers add up to 1, but they have to multiply to, I think that's 6 times negative 22, which is negative 132. So whether this factors or not, I don't know why the focus is this far off. I'm trying to do some tricks to get this to come in for me. I don't know how to help it. So I'm trying to say stuff out loud here because you might not even be able to read this if it doesn't want to change the focus to this. But that's negative 132 is my number here. I'll just write larger for a little while. I need factors that multiply to negative 132. That's a pretty tricky number for this. I need them to add up to 1. Now, when this is negative, the only way to multiply to a negative is with opposite signs. I need a negative and a positive. So I want to start off with small negative and big positive because they're going to add up to a positive. And I have to work this down until I get a positive 1. So negative 2. This divided by negative 2 is 66. This divided by negative 3 is 44. Again, this stuff, if you're good with mental calculations, it's a little faster here. But if you have to stop and calculate these division problems, if it doesn't come out even, don't even worry about it. You only care about integer factors here, kind of factoring we're doing. Um, so far, everything comes out even on this one. That's going to be 33. 5 doesn't go into it evenly, right? So if I divide it by -5, I get 26.4. I don't need decimals. I don't want that. So skip -5. -6 goes into it evenly. You get 22. I'm trying to add up to 1, and I'm getting kind of closer together. So I'm getting closer to adding up to 1, but not there yet. 7 doesn't go into it evenly. 8 doesn't go into it evenly. 9 doesn't go into it evenly. 10 doesn't come out even. -11 goes into it. And divided by -11 gives you 12. We finally got something that adds up like we're supposed to. I got a great example. That started to focus better. I don't know why. But here we go. That's the magic combination here that adds up to 1. So my P terms, going back to the box now, that's exactly what fills in. -11 and +12. Now we're home free. We just got to find the CF for the rows and columns. And this one, the negatives are across this row right here. So 1 minus will take care of all of that. I'm going to have a plus here and a minus here. GCF here is 11. Doesn't matter which row or column you do first. This row is 6P. So there's a factor. This row, now 6 and 11 don't have any common factors, but I got it. Letters, I got P. And that multiplies like it should. And this looks like a 2 right here. That those multiply like they should. You can kind of check as you go along. Make sure your little multiplications work. If those little multiplications work out, then the big multiplication is going to work out. You're going to have the right factors here. You just have to write this out in factored form. We've got them. So the best way to write that answer is using the containers here, the parentheses. That's the factored form of that thing. And that's our goal on this thing. A little preview, I guess, of where we're one of the places we're headed if you've hung in for this long. It'd be pretty hard to tell where something like that was equal to 0 because there's so many terms to it going on. But if we can get it factored out, we can find where P plus 2 equals 0 or that 6P minus 11 equals 0. It makes our equations come out simpler because something we're going to do with the 0 factor property. But this is going to allow us to take complicated equations and turn them into a couple of little simple equations once we get the factored form of it. So that's one of the things that the factoring does for us down the road. That's going to be toward the end of chapter 6. So that's a little preview of where this is headed and why you might care about the factored form of this thing, besides just having another way to write it. All right, one other example with a little bit of variety right here. We'll work this in. It says to factor x to the 4th minus 4x squared minus 12. It's actually number 151 in the book, but that's the polynomial that we're looking at here. It's got different exponents on it. That's not really going to make anything harder. And the process works exactly the same for this. Nothing weird going on here. First step is to look for a GCF on that. But it's got to be common to all of them, right? 4 goes into those, but not, there's no number here. X's, you could get a couple X's out of 2 of them, but not all of them. The only GCF, it's got to be common to the entire thing. That's all I'm worried about at this stage. And there's nothing that's in common with all terms except one. So there's no GCF to factor out. I'm ready to go with the box now. And so first term and last term go right in. This is negative 12. And that's x to the fourth. The letter part I can fill in. And this gets forgotten a lot. I see people write these things out and they get your pattern and forget the letters here. So I'm trying to make a habit of doing that first because that's going to matter when we go back and look at our rows and columns. We need this written here. It goes with that term, predictable. But so how to get it written down so we can do this. Have it in there. Now the numbers, the diagonal multiplying thing here. This is really 1 times negative 12 is negative 12. So I need numbers that multiply to negative 12 and add up to negative 4. That thing in the middle is negative 4. Multiplying to a negative, I need a positive and a negative. So one goes into this. Streams good. Okay. Times negative 6 is negative 12. And they add up to negative 4 like they're supposed to. So my inside terms, my other two terms inside the box are 2x squared and negative 6x. And the inside out part, pulling out the common factor of these two terms is negative 6. If you find your minuses in a column like that, then the minus is going to go with that column. Everything else be positive stuff. That's x squared. And in this row, we got an x squared. Another 2. All the little multiplications work out. X squared times negative 6 is negative 6x squared, and so on. So those are my factors of that polynomial. X squared minus 6, x squared plus 2. Now, one more thing to think about. An example like this. The exponent situation didn't really change any of that process, but I have to think a little bit more about it here. I have exponents left. As long as there's exponents left in these factors, I might be able to factor further. I have to worry about whether I can keep going and factor these things out some more. Maybe this breaks down into x and something and x and something, right? I'd have to think about that because I still have a squared in there. Sometimes they will. So I want to think about each of those and see if I can factor them any further. They don't look like a 3-term factoring, but we can think of them that way. So here's what I'm asking myself now. Because I got exponents left, can I factor this thing any further? And spoiler alert, the answer is no on this one, but we got to see why that is. I can think of this as the same kind of box method thing to ask if I make them into a 3-term thing. Is really x squared plus 0x minus. It's a 3-term factoring problem just like before. And I can try to factor it with the same old routine with the box method again. I don't have a GCF. I mean, the GCF is 1 squared goes in, negative 6 goes in. I need numbers that add 0 for this kind of thing. And ways of multiplying negative 6. I'm not going to end up finding anything that adds up to 0. I could do 1 times negative 6 or 2 times negative 3, or it's not the right kind of number to have something that adds up to 0. None of those are going to work. Since nothing adds up to 0, there's nothing to put in here. If there's nothing that works, it doesn't factor further. So that one is already prime. And you can kind of do the same thing here. We don't have the right kind of numbers to add up to 0 on this one either. If I do x squared and a positive 2, my number would be 2. Ways of multiplying to 2, there's not very many there. Nothing adds up to 0 on that either. So this is also prime. There's nothing to fill these in with, and so that's also prime. Should check that. Anytime I got exponents left, I got to check and see if I can keep splitting it up. But in this case, no. Both of those are prime. So that's what we call completely factored. Now I know I broke it up as much as it possibly can. And that's the completely factored form. It's actually one of the more subtle things about factoring. We have higher exponents. You might be able to keep going and factor into more pieces, but not in this case. This one's as far as it goes. I guess I want to make a connection back to the division while we're here on not that example, but one of these examples that I did. So let me make a comparison here between what factors and what doesn't. If I know the factored form of something like this one, that kind of tells me what goes into it evenly. So I'm going to write these down separately and kind of make an observation about how this works, just to link this back to what we were doing with the long division stuff. So I'm copying down that fact that 6p squared plus 1p minus 22 factors into this form, p plus 2 and 6p minus 11. And I'm going to think about how that affects some long division problems. I'm just putting this on a different piece of paper, and then I'll get this on camera here. I get them right now. But that factoring result that we got there, I copied it down. And I know the two things that are the factors of that polynomial. Factors, that means it's divisible by that thing. So if I divide it by p plus 2, I sort of know what I ought to get. That 6p minus 11 should be the result right there. But we can go through that with long division also and tie it together. But if we divide by something else, and I wrote the p plus 3 down there just because similar looking thing, it's not going to come out even. That's going to have a remainder to it that we have to think about. So I want to make the comparison there. And get a little more practice with the division stuff, which we wanted to do anyway. So off to the side, my first term is 6p squared divided by my first term here of p. I get 6p. That's the first term of my quotient then. And 6p times p is 6p squared. 6 times 2 is 12p, positive 12p. That's what I have to subtract for this one. And in the subtraction, I get 0 here, but I get negative 11p. And I can bring down the next piece on now. That's what I'm going to deal with next. Now, if you remember in the factoring thing, or if you look back at the box method factoring thing, that 1p got split into a 12 and a minus 11. I mean, this is kind of the pieces of it showing up in this form. So if you want to make some connections, there's connections there. But finishing this off, first term is negative 11p. divided by the first term is p, so that's just negative 11. That's the other part of the answer, the next term of the quotient. And so negative 11 times p is what it should be. And negative 11 times 2 is, that also matched up perfectly right there. So we get a remainder of 0, and that was the quotient. Of course, we knew that because we had that factor form. So factoring would help you with that division problem, but it wouldn't really help you with this. The fact that that polynomial there factored into p plus 2 and 6p minus 11 doesn't really help you with what happens if you're dividing by p plus 3. It doesn't really help you with that. It doesn't do much for you. We know it's not going to come out evenly, but you really don't know your quotient and remainder without going through this process. So the long division really necessary when we're going to divide something by some other polynomial that doesn't end up being a factor of it. And the process will be the same, but we won't get the 0 here at the end. So let's see what happens. Starts off with the same first term. So the same beginning for the quotient here. That 6p is the first term of my quotient. 6p times p is 6p squared. 6p times 3 is 18p. Subtract there. That's 1 minus 18 gives me a negative 17p. And I can bring down the next piece with it. Similar process, a little different numbers here so far. First term of what I'm dealing with now is negative 17p, so that's the next division piece. Negative 17p divided by p is just a number, negative 17, so that's the next term up here. And multiply that out. Negative 17 times p came out to what it's supposed to. Negative 17 times 3 came out to, well, something over here, but that's very different, right? So I have to do the subtraction, and I'll get a remainder on that. That's the difference on this. And the answer is going to look a little different. Negative 22 minus negative 51 is negative 22 plus 51. So it's going to come back to positive, was that 29? It's almost 30. Yeah, 29. Positive 29. That number is going to be just the remainder on this one. So that's kind of the difference on this. The answer to this division problem was just 6p minus 11. We had ones on the lab that had that kind of answer. Just came up to a polynomial, where the answer for this kind of division problem is going to have this polynomial up here that's my quotient plus the remainder over what we were dividing by. That whole thing would be part of the answer. Polynomial piece and the fractional piece, remainder of 29. Any preference here? I got a couple of faithfuls that are hanging in on this thing live. So if you want to do more division, or if you just want to do more factoring, there's really only a couple kinds of obscure or special forms of factoring that we have to get to where the box doesn't work on them. There's a couple of ones that we're going to do. But I really don't think we need to run into that right now. We have to get the basics down on this factoring. So trinomials, doing a GCF first and going through this box method, we have to get good with that. I will show you a little bit with the 4-term factoring ones that work out nicely on that. So let me find an exercise on that. You should see this. When we get into 4-term factoring, it's longer, but it actually gets simpler to use the box on because we got 4 blanks in our box anyway. Let me find a good example on it. generate one of these things that works out nicely. Oh, here we go. Try factoring this. Kind of like the way this other paper is going. My camera can lock in on this. We're going to look at factoring 4x squared plus 8bx minus 4ax minus 8ab. So that's what I mean by 4-term factoring stuff, is that there really is 4 unlike terms to start with. None of those combine. And so that looks longer than what we did before. But the process is actually much shorter on this thing. If it's going to factor into things that have 2 terms, then it's going to have to fit into this same box thing that we have, the 4x squared. Well, I've got 4 terms for 4 boxes right now. I don't have to mess with all this weird stuff. I just put them in. Now you might have to mess with the order a little bit. I'm taking these the way that they're written, and that's going to work out fine. But notice all of the pattern stuff is kind of taken care of already. What I mean is, these don't combine to anything, so there's nothing to add up to because none of them combine. But the pattern of this times this being the same as this times that, that's negative 32. And that's also negative 32. That's already kind of there. So if that works out okay, then we will have factors to it, but we don't have as many steps to do. We go right to filling in all the inside of the box, and then you just pull your inside stuff out, fill up, find your GCF for the rows and columns. So when we have a 4-term factoring, throw the 4 terms right into the box and see what you can take out from the rows and columns. 4x, 8b is in common there. My minuses are in a row, so the minus will be over there. This will be a plus. I'll just need a minus on this one. 4x, no. Oh, made a mistake on this one already. Negative 4a. See, my inside multiplications don't work out nicely. 4x times 4x is 16x squared. That doesn't match up. 4x times 8b is like 32bx. I got way too much going on. The reason I messed this thing up was that I didn't do my step 1. I didn't look for a GCF first on this thing. So I really shouldn't have gone into the box that these aren't going to work. They don't multiply to the right thing. I got 4s all over the place, and that's because I had a GCF that I should have pulled out first. So let me actually do this one right. So this is not quite correct. Some of the pattern of it is right, but some of it doesn't work out because I didn't do step 1. GCF on this one. Didn't expect to find one with 4 terms, but there is. 4 goes into all of those. There's no letter that's on every term. I ran out of X's. No letter that's on every term, but the GCF is 4. So I have to take that out of there first. Factor out the 4, I'm dividing by it, so I just have x squared plus 2bx minus 1ax minus 2ab. So it's still a 4-term problem, of course, but the 4 is out of the way. The rest of this should work okay. Fit this in. X squared 2bx minus ax minus 2ab. Most of this is the same, except we don't have as many numbers in here. Right? It's a smaller thing to deal with. Numbers are -2 and -2. That worked out nice. the letters, well, your GCF here is just the letter X. Your GCF in this row, this is the minus part. Common factor of A. Common factor here is X. Common factor here is really the 2B. So that's the factors of that piece. So my final answer for that thing, my completely factored form, the GCF should still be sitting out here. And then my factors are X plus 2B and X minus A. So for the 4-term factoring problems, same process, except you get to skip a whole bunch of it because you don't have to split up that middle term. It's already broken into 2 terms and they already go in separate places anyway. So there's actually a lot less to it when you have a 4-term factoring problem. If it does have this kind of factor, then the terms will just drop into the boxes. You might have to fiddle with the order of the terms, but if you get them in there, your GCFs of the rows and columns should work out just fine. That's actually kind of the easier problem to do.
Yeah. That's nice. Not up here. We have to go downstairs. This freezer doesn't keep things frozen.
Kind of seems like this is going to be a little redundant to do more of it. I don't see a point in making the video that much longer. I just do more of the same thing. I have a nice PDF handout of examples using this box method. That's what's going to come out with the notes on Monday. Is that handout, and then I'll have some videos and stuff to go with it. So I'll get those out to you all on Monday. The online homework is most likely due today, but the lab comes in Monday. So if you're still working on a lab, get that sent in to me. Pictures or scans of that sent in to me between now and Monday sometime. And I will get the new online homework up soon and handout in the lab for next week will be any announcement next Monday. So keep in touch. For some I haven't heard from yet, please check in with me if you haven't been in touch yet. We'll get that lab in so I'll know people are out there and hanging with us. Tough situation, but we're making the best of it. So keep in touch. I'll do the YouTube live again on Wednesday morning, but I'll be watching the email in between now and then in the Blackboard. So check in and let me know if you have any questions. Have a good weekend.
Is that enough?